Hey guys, remember I told you when you learn how to factor, you have to know how to factor. Well, we're still factoring, and today we are learning Lesson 6.1, simplifying fractions. These fractions are different fractions because we have to factor first. So, if you get nothing out of today, please hear me. You have to factor first. Our essential question today is, can you simplify algebraic fractions? So let's go ahead and learn number 1. Do you see this plus sign and this plus sign? Remember with fractions, if I have 3 plus 2, which is 5 over 3, remember you can't cancel out the 3's because 5 over 3 is not equivalent to 2. You have to only cancel out things that are being multiplied, like, that doesn't work, 6 over 3. So remember, in this case, these 3's can cancel out. And this is why we have to factor first, because when we factor first, then we're all at this multiplication. So over here on the top, in the numerator, I can take out a 2, and I have t plus 3 left over. And on the bottom, I can take out a 5, and I have a t plus 3 left over. And even though you can't see the multiplication, well now you can because I put it in yellow, you know that 2 is being multiplied with t plus 3, and 5 is being multiplied with t plus 3. So when we reduce, my answer is 2/5, or 2 over 5. Okay, so my biggest concern is that you know to factor first. And here I have a little reminder, do not cancel if things are connected with a plus and a minus. Okay, this happens a lot. People try to reduce. You can't reduce with a plus and a minus. So go back to what you know. Factor, factor, factor first. All right, so let's go ahead and look at example 2. Hopefully, even though we had a break, you know how to factor still. So on the top, notice I can take out a 2. And I have t plus 1. Now, you guys are rock stars with the pink sheet. T squared minus 1. Anytime I have the difference of two squares, I need a t plus 1 and a t minus 1. And now everything's being multiplied. I'm not going to put the multiplication in for you. I need you to see it on your own. And the t plus 1's can cancel out. So my final answer is 2 over t minus 1. And I like to keep the little couples together, so I keep them as a couplet. All right, now we're getting to some tougher factoring. So you guys have to remember how to factor always. So 3x squared plus 5x minus 2, I'm going to take first and last. Well, I know that 3 times negative 2 is negative 6, and the factors of negative 6 that add up to be a positive 5 are what and what? Good, there's 6 and negative 1. I'm going to use the California method because I find it super easy. So I'm going to take 3x and put it over 6, and 3x and put it over negative 1. And remember, we do this just to show that we can reduce. So 3 goes into itself 1 time and into 6 2 times. So finally, I have the top factored. And on the top, I have x plus 2 and 3x minus 1. Now, I'm going to take some time to check that. X times 3x is 3x squared. Outer is negative 1x. Inner is positive 6. Those would add up to be positive 5x. And my last terms are negative 2. So on the bottom, it's backwards. So I know I have my x's at the end. And I know that they're the factors of 6 that add up to be 1. So I know I'm going to have a 3 and a 2. But I want the 3 to be positive. So if I put the positive over here, because this is going to be the outers, I know it's going to be like that. And the inners. So from here, it looks like I could start reducing. Is x plus 2 the same thing as 2 plus x? Yes, those are commutative, so I can go ahead and reduce x plus 2 and 2 plus x. What about 3x minus 1 and 3 minus x? Can I reduce anything there? No, I can't. So my final answer is 3x minus 1 over 3 minus x. Now I always ask my students, can I reduce this 3 and this 3? Okay, because I want to keep these little couplets together, I cannot. Remember, the whole thing has to be able to reduce. All right, let's go ahead and we're going to solve this weird problem for x. So on the left, I have 4k plus x, and on the right, I have 16k squared plus 8k plus 1. Well, on the left side, do y'all see how I have an x and an x? Can't I factor those out? I can. So when I take an x out, I have 4k plus 1. Well, hopefully you're looking at this right here and saying, hey, I know how to factor that. That is the perfect squares, possibly. So I know I have a 4k and a 1. And when I multiply them and double them, hey, this works. So I know that this is going to be 4k plus 1 quantity squared. Now, I wrote that out twice because I want you to see if we have one in common here, that would cancel out. So what is x equal to here? Good. X is equal to 4k plus 1. All right, I have some practice problems, so if you could please push pause and try these practice problems, that would be awesome. Great job. I hope you guys are doing awesome.